Hi, my name is Harini Tamarisa. In this presentation, I'll walk you through my machine learning project where I built and evaluated models to predict the energy output of a combined cycle power plant. And we are working with the supervised learning, especially regression problem, since we aim to predict a continuous variable power, that is power output. I chose regression models and used RSME and R square score as evaluation metrics. The data set includes 4 environmental features: temperature, ambient pressure, relative humidity, and exhaust vacuum. And I compared several regression models: random forest, gradient boosting, and multiple linear regression as a basis. The data set has around 9,500 rows, and I used 80 to 20 split for training and data and test sets, and applied 5-fold cross validation on the training data. This strategy gives a reliable estimate of how the model performs on unseen data and reduces overfitting risk. Coming to model comparison, here is how the model is performed. For random forest, we had RSME of 3.34 and R square is 0.93, and gradient boosting showed MSE of 14.66, which is like approximately 3.83 RMSE, and R square of 0.95, and regression, linear regression, which has lower R square of about 0.93. That is exactly what I evaluated for the comparison part. And the final model selection, I selected gradient boosting method as a final model because it has the highest R square score, competitive RMSE of around 3.83, and offered better generalization than others. So, and I also compare the feature importance, like which feature has more is most important, and I see the correlation here, and temperature is turned out to be the important feature. Coming to the next steps going forward, I would like to tune hyper parameters using grid search, try more advanced models like XGBoost and Light GBM, build a dashboard for live energy output forecasting. I also compared AdaBoost versus gradient boosting. And I see that for the AdaBoost, we had an MSE of 29.77, and R square is 0.87 when compared to gradient boosting, which had MSE of 14.66 and R square of 0.95. So this further confirmed that gradient boosting is the most suitable final model. And in conclusion, to summarize everything that I did, the objective here was to predict energy output using environmental data, and model compared was like linear, random forest, AdaBoost, and gradient boosting. And I came up with the best model as the gradient boosting, where R square was 0.95 and MSE turned out to be 14 point. And the most important feature that was identified was temperature, and validation strategy that I used is fivefold. And gradient boosting provided the best performance, balance, and generalization. Thank you for reviewing my project. I'm excited to hear your feedback. Thank you.